Hello everyone. So today we will see list and dictionary comprehensions in Python. Okay. So what are comprehensions? So a comprehension is a short and elegant way to write list and dictionaries in single line. So that replaces the for loop, multi-line for loops. Okay. So here you can see this is the definition of comprehensions. Okay. So how do you write comprehension list or dictionary comprehensions? So here is the tip. So first you can write regular for loop, then you can convert that into a list or dictionary comprehension step by step. Okay. So uh, let's see sample. If we do not write a program in list comprehension, how does it look like? So in regular loop, this is you can see. So if I want to find a squares of a particular numbers from 1 to 6, this is how I write in my regular program. So let me copy this program and so let me run it here. So this is how first I'll declare. So I want to capture my output in the squares variable. So that's why I have to declare this squares variable list here. This is an empty list. So once uh, uh, I have declared an empty list, so I'll calculate uh, the list of squares by using squares dot append. So every time it generates a square, it appends my list. Okay, so here I have created my empty list. So I want to append my empty list every time for loop runs. Okay, so let's run this program. So here we can see, so 1 square 2, 1 square 2 is 1, 2 square 2, 4, 3 square 2, 3 square, so list of squares. So here you can say uh, 3 square 2, yeah, 3 square 2. So I value, so this I value will change every time. So this it will find the squares. Okay, so the same program. So if I want to write the same program in comprehension, so how do I write it? So this is how I write it. So here is the syntax. No, I'll say expression. So what is my expression? So my expression is logic. So what is my logic? I into star. So this is my squares logic. Then I'll declare my for loop for I in range 1 to 6. Then with just single lines of code, I'm able to calculate list of squares and I do not have to declare my squares variable separately. With this same variable squares, I'm able to calculate and print it. So let me run this list of squares program here. Okay, so here we can see we got the same result. So with just one line of code, we have written, we have found out list of squares. Okay, so going back to the definition, so what is comprehension? A comprehension is a short and elegant way to create list or dictionary. So here you can see we already saw what is list data type. We already saw what is dictionary data type. Now we are seeing what is list and dictionary comprehension. So in single line, we are replacing multi-line for loops while writing list and dictionary comprehensions. Okay. Similarly, I can write dictionary comprehensions. So if I do not write dictionary comprehensions, how does it look like? So this is how it looks. It look like. So this here I have created an empty dictionary and then I'm writing a for loop to loop between numbers 1 to 5. Okay, then I'm writing my logic here, then I'm printing the result here. Okay, so how many? 1 2 3 4 to the 4 lines of code. Okay, so let me execute it. So every time I calculate my result, I'm appending my result to my empty dictionary. Okay, so let me execute this. So this calculates along with key value pairs, we got the result. So Square of 1 is 1. Square of 2 is 4. Square of 3 is 9. Square of 4 is 16. Square of 5 square 2 is 25. So this is how we got. So if I want to write the same thing in just one line of code, so this is how I can write. So here is the syntax I can use. I can declare the expression, key expression and value expression. So I'll define two things here. So first I have to define what is my key. I is my key, and value expression. This is my logic, actual logic, which I have to calculate squares. Then I'll write my for statement for I in range 1 to 6. So this is just simple dictionary comprehension. So when I run this statement, so I get the same result. So with just one line of code, I'm able to create a dictionary of squares. Okay. So when do we have to use comprehension? So when to use comprehension? So let's compare. Okay. So in regular for loops, we have to write more lines of code, whereas in comprehensions, it's concise. We have to write just less, one line of code. So very less or one or two lines of code. So if we have two operations to perform. And performance wise, regular loops, they are little slower compared to comprehensions. It's slightly faster. So we'll see why it is faster also. And readability. So in terms of readability, the easy. Regular loops are easy for beginners, but as you move on to write advanced programs in Python, so once you get familiar with the comprehensions, so this comes very much handy. So with just one line of code, you will be able to do a lot of things. So you can write list and dictionary comprehensions. So what are the use cases? So in regular loops, for loops, while loops we write. So it is used for building complex logic. But when you have to use comprehensions, when you have to perform just one or two tasks, like here I'm saying cleaning or filtering and transformation. So if you want to clean the data, filter the data, perform a transformations on the fly. So with if you want to perform less logic, you can quickly write list or dictionary comprehensions. Okay. So here are some example. Okay, so I want to filter even numbers from a list. Okay, so how I do it? So I can write complete statement here in just one line of code. I'm able to filter even numbers. Okay, so you can notice this is my events variable, and what I'm saying, this is my for loop x. So this is my expression. So whatever the result comes from here, I'll capture this in X, then finally I will print it. I'll forward it to events variable, then finally I will print it. So this X variable will capture all the result that the right side part will generate. Okay. So what I'm saying, X, I'm defining X. So I'm saying capture everything after it executes. For X in range, so I'm declaring my X variable in for loop. For X in range 1, comma 11. So loop through 1 to 10 numbers and find out if there are any even numbers. So as we know, the logic of modulo, right? So if my number modulus 2 equal to 0, that means anything divisible by 2, we consider as even number, right? So that's the logic we wrote here. I hope you remember the conditional statements we learned. So we use the if condition here inside the for loop. So here you can see this is for loop, and inside the for loop, this is how we wrote if condition. So in regular uh, program, this is how you write x equal to 0 for I in range, for x in range 1 comma 11. Then go back to the next line. If x modulo 2 equal to 0, print even. Okay. or print X. So in regular program, this is how we write it. So but here you can see in just one line of program, we are able to calculate this. So if I execute this and say print events, we will be able to print the list of even numbers. Okay. So same way, so I have a dictionary along with the word length. So if I want to find out, quickly find out what is the word length of a dictionary, I can quickly write a dictionary comprehension. Okay, so I have to close my dictionary here, dictionary comprehension here. So here you can see we are able to calculate it. So if I want to print it here, I can write word length. So it will calculate how many times uh, apple, banana, cherry, how many times it occurred. So here what we are saying word and oh sorry we are not saying how many times, so we are saying what is the length of this text apple, banana, cherry. So this will quickly calculate the number of characters in a word. So same way, for data cleaning we can quickly use list comprehension. So I have a list of user inputs, name, an empty space, and none, Alice, again an empty space, again letter, again a word. So if I want to strip an empty spaces, so for data cleaning I can use this. So I can write this program. So this is my user input. So this data is not clean, so it has empty names or empty spaces or none. So what I'm saying, just clean it. So if I output this cleaned variable, then you can see, so all uh, empty names or empty variable spaces or nuns all got eliminated. So that's what x dot strip means. So it strips those uh, dirty data. Then along next use case is data transformation. So if I want to do a quick data transformation, so like I want to round the price of an item, then I can quickly do that. So here is my dictionary and here is my dictionary comprehension. So what I'm saying, item, this is my key, this is my value expression, this is my logic. So here I'm calculating through for loop dot items. So we have seen this dot items method in dictionary while we are learning dictionary, right? So it will output both key and value pairs. So we'll capture those, and then what we are saying, price into 83 at two decimal places. So if I print this, so you can notice we're quickly able to transform our data. So I'm saying apple 83, banana 41.5, milk 166. So this is how it works. Next, so if I want to do a log analysis, then see, so here is my log. So my log has these keywords. So info is my info, okay, error, disk full, info, running, error, timeout. So what I want to do is I want to get all those keywords that starts with errors, that starts with keyword error. So what I will do, I will write a list comprehension. So this is my line variable. So I'll capture all that will generate from here into line variable, then pass it on to the errors variable. So now if I run this program, so you can see it bought two list items here. This one, error, disk full, error, timeout, from my exact list. So these are the use cases of list and dictionary comprehensions. Okay. So now why comprehensions are better? So why they are better? So you may have noticed that for regular for loops, we have written 3 to 4 lines of code, but for list comprehensions, with just one line of code, we are able to execute the logic. And readability, in terms of readability, so it's medium, that you have to read lines of code one by one. But in terms of list comprehension, it defines a simple logic, and it defines that you know you're writing a program in just one line, and you know more about Python's actual way of coding, Pythonic way of coding, writing Python programs. Performance. So in terms of performance, so traditional for loop, so it's slightly slower, but comprehensions, they are faster, because these are developed internally. They are optimized in C language. So you might have remember in our very first class we discussed about byte code, machine code. So C, C is assembly language code. So it is a compiler program. So once the code is compiled, so it will quickly run on the machine. So there is no need of interpreter. So when it comes to Python, whenever you run Python, every time it checks your syntax is correct, and your it will convert that code into bytecode, then bytecode is converted into machine code. All those process will happen. But in terms of C, as soon as you compile the program, directly it will create a machine code, and it will run directly in the CPU. So that's the advantage. So it makes our code run faster. And we have declarative style in for loop. So there is no declarative style in for loop, but when it comes to list or dictionary comprehensions, it's a declarative style of writing. So, and there is no functional approach in for loops, but when it comes to list or dictionary comprehensions, so it's a functional way of writing the code. Okay, so I think so far it's clear. So let's see a simple example, performance wise, how traditional program is slower and comprehensions, list or dictionary comprehensions are little faster compared to traditional program. So okay, so here is my simple program. So I'm capturing the execution time of my program by writing this start is equal to time dot time. So after executing my program, I will minus uh, the time from the print time. So whenever I'm printing the output, I'll minus that start time, and I'll bring the loop time. Okay. So let me execute it. So this program takes uh, zero point 0.4 seconds to generate this output with traditional for loop. So I'm trying to find the list of squares from uh, from 0 to 1 lakh numbers. Okay. So same thing, if I try to execute through list comprehension, so you can see I can, it takes zero point 0.2 seconds. Okay, so this is the difference performance wise. List comprehensions, they are faster for the same amount of data. So you can see like okay. So, okay. So to summarize, list comprehensions, they are cleaner. So in one liner code, you can write common patterns, and it's faster executions because it's internally optimized in C, and it's more Pythonic way preferred in Python community. So it's more Pythonic way of writing programs, and this less error prone. No need to declare initialize empty lists or dictionaries. So as you have seen in our first program, in regular way, we had to declare our empty list to capture the output, right? But when it comes to list comprehensions, we didn't declare any empty lists. Just we calculated our logic and captured in the squares variable. Okay. So here are some programs we can execute and see. So let's see some exercises. So I'm creating a list of squares for integers 0 to 10. So this is my list comprehension. So it will quickly create for numbers 1 to 10, 1 to 10, all the squares, and find all the odd numbers from 1 to 20. So it will find all the odd numbers from 1 to 20. Here is my logic that gets that odd numbers. Okay, so generate a dictionary where keys are integers from 1 to 5 and values their cubes. So this is my dictionary comprehension. So with this, I can generate keys are keys increment by one number, and values are their cubes. So values always cubed in cubes. So one cube, two cube, three cube, four cube, like that. So generate pair I comma j for I in 1 to 3 and j in 4 to 3. So here we are doing nested for loop inside list comprehension. So here you can see we are capturing our nested for loop in two variables. So first variable data will capture in I, second whatever it generates will capture in j. So I can create list of pairs. Okay, generate pairs one I comma j for I in 1 to 3 and j in 4 to 6. Okay, so next exercise we have is replace numbers divisible by 3 with fizz and by 5 with buzz in 1 to 15. This is my range 1 to 15. Within this range, if any number is divisible by 3, I have to replace it with fizz. If any number divisible by 5, replace it with buzz. So this is how it will work. So I can also create a dictionary with parity labels for numbers 1 to 10. So here's my key and this is my value. So here you can see I have started with the logic. If my number is divisible by 0, I'm considering it as even. So what I'm saying, even. So my number is even if. So this is other way of writing. So even in regular programs we write our condition after the condition, but here in list comprehensions we can even write before the condition. So what I'm saying, even my number is even if, it's a English way of saying. So my number is even if my number is divisible by zero, else odd. For what are those numbers? For I in range 1 to 10. So this is how it generates. So list of prime numbers between 1 to 50 using list comprehension. So I can get list of prime numbers. So this is like in just one line of code I was able to write the complete program. So here we can see what I'm saying, x for x in range 2 comma 50. So what say we want prime numbers between 1 to 50. So it's starting from 2 and 51. So if so this is my condition that exactly gets me list of prime numbers. So if all x, so this is my membership operator. So what I'm saying, if it is divisible by if it is divisible, if the divisible number not equal to 0, for in this range, and integer of x into 0.5 plus 1. So I can use this formula to generate the list of prime numbers between 1 to 50. So here I have created a next nested dictionary. So I want outer keys 1 to 3 and inner keys between A to C with product values. So how can I do that? So I'll declare nested dictionary here. So I have I. So this is my key and this is my value formula. So this formula that will get me the values. So whatever the values that I am desiring for. So I want values from A to C. So what I said, I in my values logic, get me values from A to C. So I'll get values from A to C. So this is A one. One is my key, and A 97, 98, C 99. So this is how I'm able to get uh, inner keys with product values. So along with the product values also I'm able to get it. Okay, so next, so this is the last exercise. So what we are saying, generate tuples. So tuples in this manner. So x square, x cube, so on for 1 to 10, excluding numbers divisible by 2 or 5. So here I'm generating tuples. So what I'm saying, so here is my logic: x, x double star 2, x double star 3. So this will square or cube for what are those numbers, 1 to 10. Then this is my logic. So what I'm saying, exclude numbers divisible by 2 or 5. So here I'm excluding numbers divisible by 2 or divisible by 5. So here I can generate list of tuples. So this is my list of tuples. So just with one line of code, I was able to do all of those things. Okay. So in short, uh, list and dictionary comprehensions is a short and elegant way of writing programs in single line, replacing traditional for loops. Okay, so that's it for today. We'll meet tomorrow. Thank you.